Good morning, students. Happy Independence Day to all of you. Remember those freedom fighters who have fought for our nation, and today we fight to free our minds with knowledge. Now let's start our topic of today's class. Today we will learn probability. Probability is the mathematics of measuring chance. It is something where we can measure chance or guess of a particular event which can happen in multiple number of ways. Like if I say today there will be rain or not, you will say either yes or no, right? If I say today I will take your class at 8 a.m., there is only one answer, that today I will take your class. Yes, only the one answer. So there are many activities where we can get multiple number of possible outcomes. There are many activities also where we can get a fixed outcome. So where fixed outcome, so we don't have to worry about it. But where there are multiple number of outcomes, so there is the story of guessing. So like if I say ki I throw a dice, so in a dice you will get either 1 or 2 or 3 or 4 or 5 or 6. So one of the 6 outcomes will happen, but we don't know the fixed result. There comes the probability. Now, in earlier classes, you study probability with the theory of classical approach, where you learn that every outcome has same probability, means same chance. But can you think that it is really true for every event? Like if I say in rain example, if I say I can see that the sky is very cloudy. So if the sky is very cloudy, that means I can guess that the chance of raining is 80% and the chance of not raining is 20%. They are not equally likely. So basically in all the cases, most of the real cases, we cannot find equally likely outcomes. So that's why our classical approach is not a suitable process to derive probability. In this class, learn a new approach which is more appropriate, is axiometric approach. In axiometric approach, we will learn probability. We don't suppose that the outcomes will be equally likely. Okay. So learn axiometric approach. First we have to learn some terms like random experiment, sample points, sample space, outcomes, and there are types of events which we have to learn. After that we will define the definition of probability in this approach. So in this approach, first we will learn some terms: random experiment, sample space, sample points, event, etc. Okay. So first is random experiment. What is a random experiment? Random experiment is an experiment where the possible number of outcomes can be multiple, means more than one. In that case, we call it random experiment. So basically, an experiment, write it down, an experiment which has multiple number of possible outcomes, and we cannot predict the outcome in advance. Then it is called random experiment. Okay. So in random experiment, we cannot predict the outcome in advance, and it has multiple number of possible outcomes. Okay. Now, next term is, what is a sample space? What is a sample space? Sample space is the set of all possible number of outcomes is called sample space. The set of all possible number of outcomes is called sample space. It's called sample space. Okay. So we can see from an example that, let's say we are taking an example, tossing two coins at a time. Okay. Tossing two coins at a time. So in this experiment, there are how many possible outcomes? It can be, in both cases we can get head, or we can get, first one is head, second one is tail, head, tail. First one is tail, second one is head, right? Or both can be tail. So these are possible outcomes, and we cannot say that this will be our result. We cannot say in advance. So obviously this is a random experiment. It has 4 possible outcomes. So what will be the sample space? Sample space denoted by capital S. Capital S. Okay. And it is a set of all possible number of outcomes. So S equal to HH, HT, TH, AT. Okay. This is the set, and this set is called sample space. Okay. Now every elements of sample space is called sample points. These are every element of S. Every element of S is called sample points. Okay. So for this set, we can make the power set. In this set, there are 4 elements. Means in power set, there will be 2 to the power 4 equal to 16 elements. In power set, what belongs? In power set belongs all the subsets of the set. Okay. So there are all the subsets here of S. Here phi is the null set where no sample point belongs. In these 4 sets, there are only 4 single sample points. Okay. And in these subsets, there are 2 sample points. In this subset, there are 3 sample points, and this is the whole sample space. Okay. Now, why I am writing this? Because we will define event. What is an event? Event, any subset of this sample space is an event. Okay. So mathematically we can write like this: any subset of sample space is called an event. Like if I want to know about the event, like in tossing 2 coins at a time, either we will get 2 heads or we will get 2 tails. Means both will be same, either 2 head or 2 tail. So in that case, can we get that event from this set, this power set? Is it here? 2 head, 2 tail, right? 2 head, 2 tail. So this is our event. So whatever way you are define your event, you will get that event as a subset in this power set. So if I define like either our event is either 2 head or 2 tail, in that case our event is head or tail. Okay. So this is an event. Now there are different types of events. Like here you can see 5. So in 5 there is no sample points. So what kind of event 5 is? 5 is basically an impossible event. For example, like if I can say that what is the event? Here define the event of getting 1. Now tell me, getting 1, is it possible here? Because we are tossing coin. We are not throwing a die. We are tossing a coin, 2 coins. So that means there can be head, tail. But there cannot be a number. Okay. So getting a number is an impossible event here. So like impossible event. Impossible event. If in an event there is no sample point, there is no sample point, is called impossible event. It is called impossible event. It is denoted by 5. Okay. It is denoted by 5. Like we can take an example. The event of getting 1 when our experiment is basically tossing 2 coins. When we are tossing 2 coins. Now, tell me this set. This is an improper subset of this set, and in this set, all the sample points includes. So here in that case, obviously one of the outcome will be the possible case, possible result. So means in this set we can say that if this event, whatever the event is, this event obviously surely it will be possible because one of the outcome will be the result. Okay. So sure event, there is a sure event. The sample space S is called sure event. The sample space S is called sure event. Okay, we have understand impossible event, sure event. Now we will see simple event. What is a simple event? event has only one sample point, that is called simple event. Okay. Here you can see that there are 4 simple events because it has one sample point. It has one sample point head. It has one sample point head. Okay. So if an event has one sample point, it is called simple event. It is called simple event. Okay. For example, head, or we can take this event head. Okay. Now, compound event. If an event has more than one sample point, then it is called compound event. Like here you can see that except these 5, exclude the 5, so except these 4, all the events are compound events, right? Here are 2 sample points, here are 3 sample point events, so they all are compound events. So if an event has more than one sample point, it is called compound event. Okay. For example, head, tail. We can take this event. This is the compound event. Okay, understand? Simple event, compound event. Now, like said, here also for events we can take union and intersection. Let A and B are 2 events of S. Are 2 events of S, or you can write like this, where the sample space is S. I am taking this example because we can explain it better through this example. Okay. So A and B are 2 events here. Now A and B are any of these events. Okay. A union B means it includes all the sample points of A and B. A union B means it includes all the sample points in A and B. All the sample points in A and B. Like if I take, first define intersection also. A intersection B means it will include only the common sample point in A and B. Okay. Include only the common sample points, only the common sample points in A and B. Okay. Now we will take some event A equal to, take here HTTH. Okay. HTTH, this event, and take another event as this one. 2 head, 1 tail. B equal to head, 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 tail. Okay. We have taken these two events. Now tell me what is A union B. A union B will be, take all the points here, sample points. So HT, okay, TH, now HH, now HT is already here, so we don't have to take that again. Okay, so this is our A union B. All the sample points in A and B we include here. Now tell me, this event is in this set HT, TH, HH, HT, see it where it is, HT, TH, HH. So this one is our A union B, HT, TH, HH. Okay, because all the events are in the power set of it, so obviously it will be there. So this is our A union B. Now tell me what is A intersection B. A intersection B will be only the common sample point in A and B. So here HT is common in B. Yes, HT is common in B. TH is common in B. No. So there is only one common point, and that is HT. Okay. So it is HT. So this is our intersection of A and B. Is it here? Yes. This is our intersection event. Okay. So that's how we get union and intersection of events. Okay. Now we will define two important events: mutually exclusive event and exhaustive events. Okay. So mutually exclusive events. Mutually exclusive events. How to define it? If two events has no common point, if two events have no common point, then they are called mutually exclusive events. Means we can define like that: if for two events, if for two events A and B, if for two events A and B, A intersection B equal to 5, then they are called mutually exclusive events. Then they are called mutually exclusive events. Okay. Now, if we take these two events, HH, HT, are they have any common sample point? Obviously no. They are different, because each single sample, this is simple event, so they cannot have common sample point. So there is a property that simple event, note down it, simple event are mutually exclusive events. Okay. For any experiment, simple events are mutually exclusive events. Here you can see that, like if I take this event and this one, okay, in this one there is tail tail, and this one is head head tail tail. So obviously both have one common point, tail tail. Okay, so these two events cannot mutually exclusive event. Okay. Now if I take this one, this event, head 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 tail, tail head tail tail, these two events have no common sample point, so we can call these two events as mutually exclusive events. Okay. Or we can write here that, for example, head 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 tail and tail head tail tail, they are mutually exclusive event because their intersection is phi. They are mutually exclusive event. Now, exhaustive events. What are the exhaustive events? If union of some event is S, then they are called exhaustive events. If union of events is equal to S, then they are called exhaustive events. Then they are called exhaustive events. Okay. Like if we can take these two events, head, tail, tail, head, tail. Okay, these are two events. If I take union of these, what we will get? We will get head, tail, union, tail, head, tail. Its union will be head, tail, tail, head, tail. Okay. So is this S? Right? This is S. So that means these two events union is S. So that means these two events are exhaustive events. Okay. Means all the simple events together are exhaustive events. Okay. And also the simple events are mutually exclusive events. So basically all the simple events are mutually exclusive and exhaustive events. Okay. We can write it in general form. Let E1 an event head, okay, E2 as this take as E2 event 2, this take as E3 tail head, this take as event 4. Okay. Now if I take union of all these four events, E1 union, E2 union, E3 union, E4, then all its union will be equal to S, right? So it is S. That means they are mutually exclusive events. Or in general form, if I can write like this, if E1, E2 En are n simple events, or we can write like this, are n events such that their union is S. E1 union E2 union En equal to S, or exhaustive events. Okay. Now, if for every pair of EI, like for every two event, if the intersection is phi, then they are also called mutually exclusive event. If for every EI intersection EJ equal to phi, where I not equal to J, then they are called also mutually exclusive event. Then they are called mutually exclusive events. Okay. So here basically, here E1, because all the events union is S, and also their intersection, every two events intersection is phi. So that means they are mutually exclusive and exhaustive events. Okay. This you understand: mutually exclusive event, exhaustive event, simple event, compound event. Now we will define the probability in axiometric approach. We have studied functions. So here, to define the probability, we will define it as a real valued function. Okay? So first step, let S be a sample space. S be a sample space. Okay. Then probability, which is denoted by capital P, is a real valued function, is a real valued function. Okay. Defined in such a way that, defined as its domain will be the power set of S. Okay. Because power set of S includes all the events of the sample space. Okay. So our domain is power set of S, and our range will be close 0, 1, close interval 0, 1. Okay. And these functions satisfying some axioms, that first one is probability of impossible event means phi will be 0. Okay. Probability of sure event will be 1. Okay. And any other events between sure and impossible event, any other event, probability will be, for any event E other than sure and impossible event, for any event E, probability of E will be greater than 0 and less than 1. And if there are some events which are mutually exclusive, if E1 union, if E1, E2, En are mutually exclusive, events, then we can write like this: P of E1 union E2 union En. We can write it as P of E1 plus P of E2 plus P of En. Okay. And the last one, if E1, E2, these events are exhaustive events, and mutually exclusive events, then in that case this union will be what? S, and P of S is what? 1. So basically in that case we can write that P of E1 plus P of E2 plus P of En equal to 1. This is the definition of the probability, and Earlier we have discussed that all the simple events of a sample space are mutually exclusive and exhaustive events. So basically for any sample space, for any experiment, if we will take all the simple events, if we will take its union, it will be equal to the sample space. Means we can write all the simple events like this, whose sum will be equal to 1. Okay.